Okay, I'm going to go over outcome 5. This is your final assessment. Okay, so same as before, your actual assessment will really be quite similar to this one. Okay, first question then. Oh, hold on, I've spaced this out. First question, circumference of a circle is given by c equals pi d. Apologies for the dog barking, the window cleaner was here, I thought he'd gone. Hopefully that's him done now. Okay, so we've got the formula c equals pi d, which is one we've used before. It's to find the circumference of a circle. Pi doesn't change, it's either the pi button on your calculator or 3.14. Diameter here is 6, we're doing pi times 6. Type it into our calculator. Where's the calculator always go to? Can't see it. Okay, so I'm going to use the pi button, so I'm going to do pi times 6. It equals, I need to press the SD button, that comes out as 18.85 to 2 decimal places. And that would be in metres. Apologies again for the dog barking. Okay. You can also do it using 3.14, which you may have to do if you don't have a scientific calculator on you. You will get a slightly different answer. If you've written 3.14 rather than pi, then I'll know that's the reason why. That comes out as 18.84 to 2 decimal places. Okay, question 2. This time the formula we're using is displacement of the object. Displacement of the object is ut plus a half at squared. Substituting into the formula, u is 40, t is 12, so we're doing 40 times 12 plus a half times 3.5 times 12 squared. Now, if you're using a scientific calculator, you can just type that in exactly as it says. So 40 times 12 plus a half. You can put a half in just as 0.5. You've got a scientific calculator but no fraction button. Times 3.5 times 12 squared. Comes out 732. It's displacement, so that would just be in metres. Okay. If you don't have a scientific calculator, you might just need to break it down a wee bit. So do your 40 times 12. Get an answer. It's 480. And then deal with the part at the end. So 12 squared is 12 times 12. So 12 times 12 times 3.5 times a half, which is the same as 0.5, which is 252. And then just add the two together, which takes you to the same answer. Okay, question 3. Calculate the radius of a cylinder. So this is a formula that you have used before. You've used it to calculate the volume. It's just been rearranged into the form where you can calculate the radius. So putting in the information we need, the volume is 750 divided by pi times the height. Height is 8. Okay, typing that straight into the calculator, that's the square root of 750 over pi times 8. That would give me 5.46 to 2 decimal places, and that would be in metres. Again, if you don't have a scientific calculator, you might need to break that down a wee bit. You might need to do your pi times 8 or your 3.14 times 8 to begin with. That gives you 25.12. So that's 750 divided by 25.12. You might then need to do your division. Just depends how your own calculator works. 25.12. Keep hitting the wrong button. That comes out as 29.86. So that will be the square root of 29.86. Then square root it. A basic calculator will have a square root button as well. And that comes out as your 5.46. Okay, I have said this before, I'm sure, but if you have a calculator on your phone and you flip it on its side, you should get a scientific calculator. Also on your computer. Somebody showed me this. I didn't know this before. If you go into your calculator on your computer, up here, it's just out of shot. Let me just move this slightly. It says standard. Oh no, that didn't work. There is a way of changing it to a scientific calculator. I've forgotten how to do it. Oh yeah, you can put it onto scientific calculator there. It doesn't give you a fraction button, but it does give you maybe some of the other buttons that you would need. Okay, have a play around with it before you use it for your actual assessment. Make sure you're happy with it. Move my screen back over. That's not what I meant to do. Okay, number 4. Acceleration of an object is flight is given by the formula A equals v squared minus u squared all over 2s. Now, if you've done any kind of physics, you'll probably recognise that formula. It's been rearranged. It's usually v squared equals u squared plus 2as or something like that. I can't quite remember it now, actually. Brain's gone blank. Okay, we want to calculate the acceleration A when v is 550. So v is 550 squared minus u is 40 minus 40 squared over 2 times 300. Okay, and a nice scientific calculator then, really straightforward. Multiplying your fraction, 550 squared minus 40 squared over 2 times 300, which I'm sure you already know is 600, so you could just put it in straight as 600. That comes out as 501.5. Again, if you don't have that scientific calculator, do your top line, do your bottom line. So if you don't even have a square button, 550 times 550 gets you 302,500. Take away 40 squared, it's 1,600. Divided by 600, do your top line, then you divide by your bottom line. So 300 minus 1600 comes out as 300,900 divided by your 600. It's 501.5. It's acceleration, so that would be meters per second to the minus 2. Number 5, a time swing of a pendulum is given by the formula below. So t equals 2 pi times the square root of L over G. We want to calculate t. So it's 2 pi times the square root of 3.6 divided by 9.81. Doing 2 pi times the square root, and I'm just going to use my fraction button, 3.6 over 9.81. It equals, and we get 3.81 to 2 decimal places. Okay, if you do not have your scientific calculator, again, just break it down. So you're doing that as your 2 times 3.14 times the square root of, and all I'm going to do to begin with is my 3.6 divided by 9.81. It comes out as 0.37. 2 times pi, or 2 times 3.14 is 6.28. I don't believe I just did that in a calculator. So it's 6.28 times the square root of 0.37 is 0.61. Multiply the two together and we get 3.82 doing it that way. That can just be in the rounding, as long as you've shown the step-by-step working. If you're doing it this way, not just typing it into your calculator, a wee difference in rounding like that makes absolutely no difference. Okay, last question then. The bending momentum of a phosphorus structure is given by M equals FL, where F is the force applied in Kn, and L is the distance in meters. Calculate the bending here. So F is 23.5, L is 2.9. Nice straightforward one for the last one. 23.5 times 2.9 is 68.15. Your units, if you want them, would be KN. Okay, as ever, any issues, any problems at all, please get in touch, let me know. Once you're ready to sit, let me know as well. Okay, good luck guys.